Alright, so we are back again, and today we are going to talk about relations, mappings, and functions. Okay, relations, mappings, and what? Functions. We're going to begin with relations. Alright, now in our everyday life, we are mostly concerned about the relations that exist between two things. Now, these two things could be anything. It could be names, okay, places, food choice, and then so forth. We're having these few examples. The first one is saying that John schools at Achimota SHS. Now, the two things we are comparing, or the two things we are talking about over here, are John and what? Achimota SHS. And the relation between them is schools at. Okay. The second one is saying Mary works at Barclays Bank Limited. So now the two things over here are going to be Mary and what? Barclays Bank Limited. And the relation between them is going to be works at. Alright, the third one is saying Smith is the father of what? Mark. So Smith and Mark are the two names that we are comparing and talking about over here, and the relation between them is the father of. Okay, alright. Now you see that the relation starts from the names you're having on the left, okay, and then it relates to the names or the items you're having on the right. So we can collect the names you're having on the left, okay, to form a set, and that is what I normally refer to as the relating from. Okay, the relation we are talking about relates from the set of names you're having on the left, and then we can also collect the names you're having on the right, okay, to form another set, and that is what I normally refer to as the relating to, just to give you a fair idea about the relations you're talking about. Okay. Alright, let's consider this table as well. This table, which has names of students on the left and then the schools they attend on the right. As we said earlier, we can collect the names on the left and put them together to form one set. Okay, and that's the set that we refer to as, or I refer to as, the relating from. Okay, the relation begins from the names we have on the left, and then we can also collect the particular names you have on the right, okay, and then to form another set, and that is what I refer to as the relating to. Okay, so the relation begins from the names on the left and then relates to those on the right. Alright, now another way that we can represent the above information, okay, the information we have in the table, this information, is by using an arrow diagram. Okay, by so doing, we are going to collect the names on the left and put them in a set, as you can see over here, and then we are going to collect the individual names you have on the right and put them also in a set, as you can see over here, and then begin to relate them accordingly. So from the table, John schools at what? Achimota SHS. Okay, so John will be related to Achimota SHS. Then Mary schools at Wesley Girls SHS, so we relate Mary to Wesley Girls SHS. And then Smith schools at Hilltop, so Smith to Hilltop. And then also when you come down here, Mark schools at Achimota SHS, so from Mark to Achimota SHS. And then Rose schools at Hilltop as well, so Rose to Hilltop SHS. Now this is another way that we can show the relation between the students and then their corresponding schools. So the names on the left relating to their corresponding schools on the right by the associated arrows, and the relation between them is schools at. Okay, so you can pick any of the names on the left and then use a relation to relate to them. So John schools at Achimota SHS, and so forth. So in simple terms, we can say that a relation associates elements of one set to elements of what? Another set. Okay, So when you look at the arrow diagram we just saw in the previous slide, we are having one set which contains the names of the students, and then another set which contains their corresponding schools that they attend. Okay, and then they are being related by the relation given above. We can also say that a relation connects two sets. Okay, so the relation connecting these two sets is what schools at, as you can see at the top over there. Okay, so that relation is connecting the set on the left to the set on the right. Now let's talk a little more about the arrow diagram we have in the previous slide. Okay, if you look at the diagram, we said earlier that we have one set on the left which contains the names of the students, and then one set on the right which contains their corresponding schools that they attend. Okay, now there's a special name given to this set on the left. Okay, we normally refer to that as the domain. Okay, the domain of the relation. And then the set on the right is having the special name codomain. Okay, codomain. So what we are saying is that if you collect the names on the left and you put them in a set, okay, then that becomes the domain of the relation. Okay, and also when you collect the names you have in the right and you put them in a set, then we call that one the codomain. So these are the elements of the domain, and then these are the elements of the codomain. Alright. Now relations can also be shown as what? Ordered pairs. Okay, let me bring back the arrow diagram again. Now these relations can be shown as what? Ordered pairs. When we see ordered pairs, we're trying to say that you pick one element from the domain and its corresponding element in the codomain, and then you put them together as a pair. Okay, so that's what we are saying. You pick John and the schools that John attend to form one pair, and also Mary and Wesley girls to form another pair, and then Smith and Hilltop forms another pair, and then Mark and Achimota forms another pair, and then the last one, Rose and then Hilltop, also forms another pair. So one element from the domain and its corresponding element in the codomain to form an ordered pair, as you can see over here. Okay, so normally the quantities that we connect in mathematics are variables or numbers. Okay, for example, we can have this set being our domain. Let's name that one set X. Then also we can have another set like this as our codomain. Let's name that one set Y. So these are variables that have been connected by a given relation, and so we can see that the domain is in the set X, and then also the codomain is the set Y. Alright, another example, we can also have a relation which looks like this, and for this one we can say the domain is the set P, okay, and then the codomain is the set R. Alright, we also have something called image and range. Let me use one of the relations that we just discussed in the previous slide to explain image and range. Okay, so what we are saying is that if an element in X, for example B, I'm selecting this element B in set X, okay, so if an element in X, okay, is related to an element in Y, which is R, then we say that R is called the image of B under the given relation. Okay, so if we select an element B in a set X which relates to R in a set Y, then we see that R is the image of what? B. Alright, so as you can see, each of the elements you're having in set X is having its corresponding image in what? The set Y. Okay, so the image of A is what? P, and that same P is the image of what? D. Okay, so we say that P is the image of what? A and what? D, because A is related to P and D is also related to what? P. P. And then Q, this Q over here is the image of C, because C is related to Q. And then also we can say this R over here is the image of what? B. So R is the image of B. Alright, now these images we are having over here, which happens to be all the elements of the set Y, when you collect them and put them together in a set, okay, then you get what we call the range. Okay, so then we say the range is the set of all images. The range is a set of all images. So this relation that we have over here, you collect all the images we are having and put them in a set, and that is what we call the range. Alright, let's look at another example. When you have a relation like this, okay, as you can see, 1 is related to 2. So you can say 2 is the image of what? 1. Okay, and then 2 is relating to 4. So we can say 4 is the image of what? 2. Then also 4 is relating to 8. So we can say 8 is the image of what? 4. Now 6 is not an image of any of the elements you have in the domain. Okay, 6 is not an image of any of the elements you have in the domain. So now what do you think is going to be the range? Okay, don't forget we said earlier that the range is a set of all images, and then 2 is an image, 4 is an image, and 8 is also an image. Okay, so then the range is going to be the collection of these images. So then we say the range is going to be 8, 4, and what? 2. Okay, but you agree with me that if you want to talk about the codomain, the codomain is going to be all the elements of the set R. Okay, so 8, 6, 4, and what? 2. That is the codomain. Now when you look at the elements in the range, they all can be found in the codomain. Okay, like 8 over here can be found here in the codomain. The 4 can also be found here in the codomain. The 2 in the range can also be found in the codomain. So the set which forms the range happens to be a set which can be found in the codomain. So then in mathematics we say that the range is a subset of the codomain. Okay, the range is a subset of the codomain because it is a set which can be found in the codomain. Alright, now this is another example that we are going to talk about under image and range. When you look at this relation, 5 is relating to 1. Okay, so 1 is going to be the image of what? 5. And then 15 relates to 3. So then 3 is the image of what? 15. Okay, but then there is an element over here in the domain 10 which has no image. So if you want to talk about the range, we know that the range is a collection of the images in the codomain. So the range is going to be 1 and what? 3. Okay. Alright, thank you very much. In the next video we are going to talk about types of relations. Okay, types of relations.